Hello everyone, welcome back to our math room. In this video, we are going to learn about a lesson in general mathematics, and this is the part 2 of our topic about finding the properties of rational functions with examples having holes in the graph. In the previous video about rational functions, we defined and discussed how to find each property of rational function, referring to the domain, range, asymptotes, and intercepts. As you can see in this slide, this provides the summary on how to find each property. Now, let us apply these properties to our example. In order to find the domain of this function, we need to look at the denominator, so we have 2x minus 1, and then we have to equate this to 0. In doing this procedure, we will be able to find the value of x, so we have 2x is equal to 1, divide both sides by 2, so we have x equals 1/2. So what is the meaning of this? This is the value that must be excluded in the domain of the function. Therefore, we have the domain set of x such that x is not equal to 1/2. And once that you already have the value of the domain, you can now easily find the value of the vertical asymptote. So for the vertical asymptote, we have the same procedure. Therefore, x equals 1/2 gives us the equation of the line of the vertical asymptote, meaning to say, this is the line where the graph will not pass through. For the range, we can find the range of this function by looking at the horizontal asymptote. Therefore, for the horizontal asymptote, remember to look at the degrees of the numerator and the denominator. So for the numerator, since this is a linear function, we have a degree of 1. And for the denominator is also a linear function, so we have the same degree. Since n is equal to m, take note that in getting the horizontal asymptote, we need to get the leading coefficient of the numerator, and that is 4, and then the leading coefficient of the denominator, which is 2, and dividing these two, we have y equals 2. So this gives us the horizontal asymptote, y equals 2. Since this is the equation of the line in the y-axis that the graph will not pass through, this is also the value of y that is excluded in the range. So we have set of y such that y is not equal to positive 2. For the oblique asymptote, always remember that if there is a horizontal asymptote, you do not have an oblique asymptote. We cannot have both horizontal and oblique asymptote in one function. How about for the x-intercept? To find the x-intercept, we need to let y be 0. And here, we will be able to find the x value. So the y in the function is the f of x, so we need to put here 0, and then just simply equate the numerator to it. So we have 4x plus 3 is equal to 0. Solve for the value of x, we have 4x equals negative 3. Divide both sides by 4, so we have x equals negative 3/4. We need to have an ordered pair in writing the x-intercept. Therefore, we have negative 3/4 for x, comma, 0 for y. So this gives us the x-intercept. How about for the y-intercept? It is the value of y when x is 0. So we need to change the x to 0 in our function, so we have y is equal to 4 times 0 plus 3 over 2 times 0 minus 1. Or, always remember that if the term has a variable x, that term becomes 0. So in this given, we have y is equal to 3 over negative 1, which is equal to negative 3. So this value gives us the y-intercept. So we let x be 0 and y is negative 3. Always remember that not at all times the general rule can be applied in finding the properties. There are cases in rational function where we could easily find the properties when we graph them. For this example, we have the function x squared over x squared minus 1. As you can see, numerator and denominator are both quadratic expressions. And in order for us to find the properties, we could easily find them by just analyzing the graph of this function. For the domain, we have to look at the x-axis and identify what points on the x-axis the graphs did not pass. and these are the values -1 and +1. Therefore, for the domain, we have the set of x such that x is not equal to -1 and not equal to +1. And to check if this is right, you may look at the function, observe the denominator, and equate it to 0. And by doing that, we will be able to have the same values. As for the range of this function, we need to look at the y-axis of this Cartesian coordinate plane. As we can see, the three graphs have different y values. So for this bottom part of the graph, we have this as the highest point, and then the graph decreases without bound, meaning to say it goes down infinitely. We could say that the range of this graph is y is less than or equal to 0. So that is the first value for the range. Or, for these two graphs, as we can see, both of them are not passing through 1. So we need to say the values of y are greater than 1 because these two are moving upward continuously without bound. So we have or y is greater than 1. So this is the range of the function. As you can see, if we're going to find this based on the function alone, we cannot be able to find this. Therefore, once again, it is best to have a graph of this function. How about the vertical asymptote? Do we have the same values as with the domain? Yes, we have. As we can see, this is where the vertical asymptote is located, and also at this point. Therefore, the vertical asymptotes are x equals -1 and x equals +1. How about the horizontal asymptote? As we all know, horizontal asymptote is the same with the range. However, in this function, we cannot follow what is written in the range because always remember that a rational function can only have at most one horizontal asymptote, meaning to say it could only have 0 horizontal asymptote or 1 horizontal asymptote. And looking at our graph, the horizontal asymptote is located at this point, y equals 1, meaning to say these two graphs of the function do not pass through point 1 on y. So we have y equals 1 as the HA. And since the HA exists in this function, the oblique asymptote is not present. So we have to write the word none. How about the x-intercept? What value of x on the x-axis the graphs pass through? That is at point 0. This gives us the origin. Therefore, when y is 0, x is 0. How about the y-intercept? The y-intercept can also be found at this point, which is the origin. So we have 0, 0. So if we are going to check our answers for this function, only the range cannot be found by analyzing the function alone. Therefore, that gives us an idea that not at all times we could apply the general rule in finding the properties of a rational function. So what are the important things we have to take note about the asymptotes? First, a rational function will never cross a vertical asymptote, and there could be no vertical asymptote, one or multiple vertical asymptotes. A rational function may or may not cross a horizontal asymptote or an oblique asymptote, and take note that there could only be at most one horizontal asymptote or oblique asymptote, and we cannot have both horizontal and oblique asymptote in one function. Third, an oblique asymptote exists when the degree of the numerator is 1 more than the degree of the denominator. For this third example, as you can see, we have linear in the numerator and quadratic in the denominator. And for us to be able to find the properties of this, let us analyze the graph provided. So as we can see here for the domain, the graphs did not pass through -3 and +3. Therefore, we could write here set of x such that x is not equal to -3 and not equal to +3. And if we're going to look at the function alone, the denominator x squared minus 9, when you equate this to 0, gives us the same values that are excluded. As for the range of this function, as you can see in the y-axis, we have a graph that goes upward continuously without bound, and this is the graph. And there is another portion here that goes down continuously without bound. Therefore, we could say that the range contains the set of real numbers. How about the vertical asymptote? Observing this graph, the graphs did not pass through -3 and +3. As for the vertical asymptote, if you're going to observe this graph, we have a line here that passes through -3 and a line that passes through +3. Therefore, we have x equals -3 and x equals +3. How about the horizontal asymptote? Do we have it here? Yes, we have. If you're going to look at this graph is moving to the left continuously and will never cross the x-axis. Same is true with this. This portion of our graph will go to the right continuously but will never touch the x-axis. Therefore, the horizontal asymptote is located at y equals 0. However, in the middle graph, as you can see, this graph passed through the y equals 0, and that is possible. Remember, in the previous slide, I told you a rational function may or may not cross the horizontal asymptote. How about the oblique asymptote? Since the HA exists, the oblique asymptote does not exist in this example. How about the x-intercept? We have a point here at the origin that gives us 0, 0. Same is true with the y-intercept. It is found here at the origin, therefore we have 0, 0. So in this function, we can now conclude that the value in the horizontal asymptote is not always the same with the range of the function. Another one is, for the horizontal asymptote, the graph passed through the horizontal asymptote, and that is possible. What else do we have to take note about rational function? It is about the hole in the graph. So the question now is, when does a hole exist in the graph? Take note that the hole occurs when same factors of the numerator and denominator are cancelled. However, when the denominator does not cancel a factor, it produces a vertical asymptote. Let us now have an example. Let's say we have the function x squared minus 3x minus 4 over x plus 1. In order to find the domain, we need to equate the denominator to 0, so we have x plus 1 is equal to 0 and x is equal to -1. So this is the value that is excluded in the domain. So we have set of x such that x is not equal to -1. As for the range of this function, if we're going to look at the function, we can find the factors of the numerator. So we have f of x is equal to the factors of the numerator, which are x minus 4 and x plus 1, all over x plus 1. If we're going to look at the function now, we have the same factor in the numerator and in the denominator, so we can cancel this one. So the function can be simplified to x minus 4, which is a linear function. So what is your idea if we have a linear function? A linear function has a graph which is a slanted line. Later on, I will be showing you the graph of this function. So how are we going to find the range of this function since it has a slanted line? Since in the domain, -1 should not be included, what is the partner of this value in y? How are you going to find it? By substituting -1 to our simplified function. So we have y is equal to -1 minus 4. This gives us -5. What is the meaning of this? If x is not equal to -1 for the range, y is not equal to the partner of -1 in x, which is -5. So this is the value that is excluded in this function. How about the vertical asymptote? If we are going to look at our simplified function x minus 4, we do not have anymore a value or an expression in the denominator, meaning to say this function does not contain a vertical asymptote, so we have to write the word none. How about the horizontal asymptote? If we are going to look at the simplified function, we only have x minus 4. So we cannot compare the degree of the numerator and the denominator since we do not have a fraction anymore. Therefore, the horizontal asymptote is also none. How about the oblique asymptote? If we're going to look at the original function, the numerator's degree is higher than the denominator's degree. So what does it mean? There is no horizontal asymptote, but it has an oblique asymptote. Recalling how to find the oblique asymptote, we need to divide the numerator and the denominator. And we were able to do it. We were able to divide the factored form of the numerator with the denominator, and we were able to get x minus 4. So the oblique asymptote of this function is y is equal to x minus 4. It is the function itself of the simplified function of the given. In x-intercept, we have to let y be 0. So using the simplified function, we have y is equal to x minus 4. We need to let y be 0. So we have 0 equals x minus 4. We now have the value of x, which is equal to 4. Therefore, the x-intercept is the ordered pair 4, 0. Meaning to say the graph of this function passed through at this point. As for the y-intercept, using y is equal to x minus 4, we need to let x be 0. So we have y equals 0 minus 4. This gives us y equals negative 4. This means the y-intercept x for 0 and y negative 4. For you to be able to check if these properties that we have written are all correct, we should look at the graph of this function. Using Geogebra as the graphing software, we can have the graph of the given function. If we're going to look at this graph, it is a slanted line only because when we simplify it, we were able to have a linear function, f of x is equal to x minus 4. Now, if we're going to compare this linear function to our rational function, the only difference is that there is a value in the rational function that must be excluded, and that is the point negative 1 and negative 5. Let us have another example. We have here function x squared minus x minus 6 over x squared minus 9. If we're going to look at the given function, both numerator and denominator are quadratic expressions. And if we're going to find the domain of this function, we will just simply equate the denominator to 0. So we have x squared minus 9 is equal to 0. Since this one is difference of two squares, we need to find the factors, which are x plus 3 and x minus 3. To get the values of x, we need to equate this to 0. So we have x equals negative 3 from this, and x equals positive 3 from this. So these are the two values that must be excluded in the domain. Therefore, we have x is not equal to negative 3 and not equal to positive 3. How about the range of this function? Looking at the function, both numerator and denominator are factorable. So we need to simplify the function. So we now have f of x is equal to the factors of the numerator, which are x minus 3 and x plus 2, and the factors of the denominator, which are x plus 3 and x minus 3. We have same factor in the numerator and the denominator, which is x minus 3. So we need to remove that x minus 3. Afterwards, we can now have the simplified function, which is x plus 2 over x plus 3. If we're going to look at the simplified function, this results to another rational function. If we have a rational function, always remember that it contains vertical asymptote and it contains either horizontal or oblique asymptote. So let us start first with the vertical asymptote. So for the VA, equate the denominator to 0. So we have x plus 3 is equal to 0. This gives us negative 3. So this is the vertical asymptote. The graph of the function will not pass through at x equals negative 3. Now, how about the horizontal asymptote? If we're going to look at the simplified form, we have numerator's degree and denominator's degree that are the same. Therefore, we need to get the leading coefficients. So we have here 1 over 1, which gives us 1 as well. Therefore, the horizontal asymptote is located at y equals 1. Now, how are we going to find the range? First, since we have the horizontal asymptote, this gives us the first value. Y should not be equal to 1. But aside from this, Since in our domain, aside from the -3, okay, just like in the VA, we also have a value that is excluded, which is the +3. If +3 is excluded, we need to find the value of y that is the partner of x equals 3. So how are we going to do that? We need to substitute x equals 3 to our simplified function. So we now have y is equal to 3 plus 2 over 3 plus 3. This gives us 5 over 6. Meaning to say, aside from y not equal to 1, y should not also be equal to 5 over 6. Since the horizontal asymptote exists, the oblique asymptote does not exist. The x-intercept is taken from the simplified form. We have to equate the numerator x plus 2 equals 0 and then solve for the value of x, so we have x equals -2. So with this, we can now write the x-intercept -2, 0. How about the y-intercept? For the y-intercept, we need to let x be equal to 0. So we have y is equal to 0 plus 2 over 0 plus 3, which gives us 2/3. Therefore, the y-intercept is the ordered pair 0, 2/3. This is the graph of the given function. So if we're going to look at the graph, this is the graph of the simplified form. F of x is equal to x plus 2 over x plus 3. And again, how is this different from the original function? Aside from having this vertical asymptote that is excluded, there is still a value of x that is excluded in the function, which is the +3. And at the same time, aside from y not equal to 1 that is excluded, we also have another y value that is excluded, which is y equals 5 over 6 or 0.83. After providing you different examples of rational functions and finding their properties, it is now time to check your understanding. You may pause the video to answer this problem. Let us now check your work. Here are the properties of this function. And like what I've said, for you to be able to make sure if your answers are correct, you may sketch the graph of this function using a graphing software just like the Geogebra. So here, as you can see, we have a slanted line and we have a point that is excluded, which is -1 and -2. How about the next function? Again, you may pause the video to answer this one. Let's check our work. Here are the properties of this given function. And again, to check if our answers are correct, you may look at the graph of this function using a graphing software just like this. Were you able to answer all of these problems? If yes, great job. If you still have questions regarding this topic, you may use the comment section in this YouTube channel. Kindly type your question there and I will be answering all of your questions. So once again, thanks for watching. I hope you have learned a lot in this video. Please don't forget to like, comment, and share this video. Thank you and see you all on my next video.